Okay, so this is a group problem or a sample problem. This is a nice problem because it has all the ingredients from this chapter. So it's like a nice summary. So I would like you to take a minute to try to solve this problem on your own and then come back to the video to watch the solution. So we have member AB, right? And that member AB is rotating about A. So this member is just doing a pure rotation, and then it is attached. So we have member BC, and then we have this piston that moves in this straight line, and you have here a 3, 4, 5 angle, right? So you have member AB, and then you're given the angular velocity of A and the angular acceleration, right? And then notice the signs of the angular acceleration, angular velocity. So this is positive and this is negative. So, and you want to find what? You want to find the velocity and acceleration of C if you know these two. So just think about it a little bit and then come back to the video. So stop the video now and try to solve the problem. Okay, so if you did that, if you solve the problem, even if you got stuck, so now you're ready to look at the solution. So let's look at the solution. So the first thing is to solve for the velocity and acceleration of B. So that's a pure rotation, so it's just very straightforward. So the velocity is omega r, right? And so it's 4 times 2, 2 in the j direction. So that's 8 meters per second. So now we have a normal and a tangential component. The normal component is omega squared r. So that's 4 times 2, that's 32 meters per second. And the tangential component is alpha r. So that's minus 5, 2, and that's minus 10 meters per second. Notice that this is the minus here, and it has to do with the fact that this is clockwise, right? So this acceleration here, and this is counterclockwise. Okay, so we have the motion of B. So now we can write those in vector form. So the velocity of B is minus a in the x direction, and the acceleration is 10I minus 32j meters per second squared. Let's remember that because we're going to need that in the future. So now we need to write velocities and accelerations of point C. See how to do that? So let's start with the velocity of C, and then we're going to use our equation. The velocity of C is velocity of B plus the velocity of B relative to C, the rotation part, right? So now we need to write the velocity of B, and this is a trick here. We need a unit vector in this direction here, right? So we need a unit vector in this direction. So you have this 4, 3, 2 angle, right? So you can write that vector as minus 4i minus 3j. So that's your vector in a vector that goes in this direction, and then you can divide by 4 squared plus 3 squared, and so and that'll give you the unit vector, right? So that's a unit vector in this direction. That's this guy here. That's that guy there. So now you can, now that you know that vectors, and we can write that and we can do that because we know this guy is moving in a straight line here, right? So the unit vector times BC is equal to what? Is equal to the velocity of B, which is this vector here, plus the acceleration of C relative to B. So that's omega k, sorry, the velocity of B relative to C. This is velocity, so that's omega BC in the k direction. And then you have this vector that goes from here all the way here, and then you can find that vector by using these 2 and 0.5, which is 2 and 0.5. So, okay, so now that we wrote that, we can go ahead and simplify this into x and y components and x and y components, and then we can solve for omega and alpha, and that's what we get, omega and alpha. So now we have the velocity of c. So the next thing is to find the acceleration of c. And so we used our equation again, right? Acceleration of c is acceleration of p plus the rotational part, and this has a tangential acceleration and a normal acceleration. So again, we use that unit vector that we calculated before. So this is going to be our unknown here. So we know the acceleration of b. This we calculated initially because this is a pure rotation here. B is doing a pure rotation. And then we have this number that we don't know cross this vector here. And we have omega squared here. And then we have that vector again. So, and that's it. So now we can simplify this equation a little bit and notice that we have two unknowns, right? So, and we have two equations, one for the x and one for the y. So we can write those two equations. And finally, we can solve those two equations to obtain the final solution.